that totally is based upon this one. So here, looking at this curve, we can get much clearer. So that means the maximum value is occurred here. When the value of the cosine equal to 1, so that means when 2 theta equal to alpha, then the value of the cosine equal to 1. So when 2 theta equal to alpha, the maximum value, the tau maximum will occur. Okay? Yes or no? We simply look at the curve. And then what is alpha? When 2 theta equal to alpha, what is alpha? Alpha is this triangle here. I keep it. So this is the triangle. This is the information about the trigonometry here. So what is alpha? Alpha is given by this triangle. We can express alpha in terms of sine, in terms of cosine, or in terms of the tangent or cotangent, etc. And here for our formula, we take up the tangent, so you can see what is alpha. Alpha equal to tangent of sigma x minus sigma y divided by 2 tau xy, right? By looking at this triangle, the alpha equal to this arctangent, sorry. Okay? Then when theta equal, so that means for this case, when theta equal to alpha divided by 2, the maximum occurs per our definition. When the maximum normal stress occurred, we define that is a principal direction. So this basically here is when theta equal to theta p. Okay? And then what is alpha? We have the information there is arctangent, and then tau xy and sigma x minus sigma y divided by 2. So you can see this value is what we have done here. Okay? Okay? Yes or no?
Yeah.
And I'm going to proceed. Okay. And so now for this case, what is the minimum value? The minimum value is occurred here. If we only take one cycle, then the minimum value, then you use a different color. At this point, when theta equal to this one, when 2 theta, when 2 theta minus alpha equal to, for example, pi, so that means if we want to get the minimum value, then we simply make this argument. When this argument equal to 0, then cosine 0 equal to 1. That's corresponding to maximum value. When this argument equal to pi, then cosine pi equal to minus 1. That's corresponding to the minimum value. Okay, so that means the difference between the two places is equal to pi. So that means when this occurs, then the minimum value occurs. So that means here the theta p, the other value of the theta p will be equal to alpha plus pi over 2. And what is alpha? Alpha is what we have done earlier. Okay. And actually, if we do because the period, the curve is cyclic, so basically here the minimum value could be also here. So again, that is the difference minus pi. So here to make that general, basically plus or minus will be good. Okay. So in this way, for your calculation, you simply adopt the equations in, for example, on the cheat sheet or in our textbook or even in my lecture notes. You just do the calculations. Okay, and in this way, if you know the information, you'll be good. We can try one example to see. Okay, so here for the numbers, I only write on one side. The other side are in equilibrium, so let me ignore that one. So for this case, for example, say if we want to find theta p, and we want to find the maximum, and we want to find the minimum. We want to find the principal. Those are called the principal stresses. Principal stresses means minimum and maximum both. And this one is called the principal direction or principal angle or principal orientations, either way. And the principal directions could be multiple values. From here you can see. The principal value could be occurring here or could be occurring here. We simply pick one. Okay. So for this one, we simply plug into the calculations. And for the calculations, can I use these small blocks for calculating things? So for example, here we do the calculation, the minimum, we calculate the average. The average is the average of the normal stress is 6 plus 10. Sorry, this should be 4. I'm making the numbers good for the good number. Okay, so this would be 7. And the R equal to, we plug into calculations. So the first one is the 10 minus 4 divided by 2 squared plus 4 squared. I'm making the number that one R equal to 5. So I've changed the there, okay? So in this way, the maximum value and minimum will be equal to the average plus minus R. So that will be equal to 7 plus minus 5, and that will be equal to 12 and 2 values. Okay? Yes. And then we can calculate theta p. Theta p is arctangent. You can see right now the calculation is very straightforward. Just plug into the formula here. That one is tau xy, and what is tau xy? That's 4. And that one is the 3. Okay, anyone has any questions? Why I come up with the 2 numbers here? Here, right? 1 half. Yeah, sigma 10 minus 4 equal to 6. 6 by 2 equal to 3.
No, I mean it's 1/2 inverse tangent.
From the
1/2, sorry. Yes. Okay, so arctangent 3 over 4, 53 degrees. Believe me or not, you have your calculator, you punch it. You see, I don't have anything written, I just come up with the numbers right away. Don't look at me at that one. Okay, so that is 27.5. Okay. So far so good, right? So now I want to show is the most critical part is how could we display the result into the right orientation. So that means right now for theta p is 27.5 degrees. So from here we make an angle 27.5 degrees. And in that orientation we have the block we're going to show. So in this way, look at this carefully. So that is applied. They put that paper away. So this is our original orientation of the stress element. Right now we rotate by 27.5 degrees. Then in this way, a line is we define as the x prime, and this one is y prime. Okay. So that means this xy rotated 1x x prime y prime. In this plane, yes. In this plane, we have the right now we have calculated the values of the principal stresses. One is 12, one is 2. The question I'm asking you is the 12 and 2 are the principal, are the normal stress. And the normal stress is either side. I want to ask you, 12 is here or here? Can you tell? From those calculations, we won't be able to tell exactly how to place the stresses onto there. We have an issue, yes.
Well, isn't the equation the max is the x prime equation? So
this is what I make up.
Oh, okay.
If you like, you can cross it out. I don't know yet. So now we have those calculations. How are we going to determine which is which? The most straightforward way is this. You just simply do one more calculation. You have sigma x prime theta calculated one more time to see what happens. So for example, here we calculate sigma x prime at 27.5 degrees. Okay, and we do the calculation one more time. So that will be equal to the average is 3, the average is 7, and plus 3 times cosine 53 degrees, and plus 4 times sine 53 degrees. Okay, we'll simply do this calculation, and then that'll be 12. So we know that the 12 will be in the x prime direction, so that 12 will be here. Okay? And here should be 2.
If you did that and it didn't equal 12, would that mean you know that it wasn't that way? It was the opposite?
Yes. Yeah. So the question is, if I come up with this will be 2, then there will be 2. The 12 will be on the other, in the other way.
Oh, you'll only either get 2.
Either way.
You wouldn't get some other random number like 8.
No.
Okay.
The guarantee this will be either one of the numbers we've been calculated. Okay. And now for this case, I want to demonstrate this. The maximum value here right now in our calculations for this example, the maximum value is theta p equal to 27.5 degrees here. Okay, so that is the value here. Then the minimum value is occurred here or here. The minimum value is this number plus or minus pi over 2. So what that means? So that means based upon, right now we are given this, and we rotate 27.5 degrees, and in the x prime direction, that gives us the maximum. And now if we would rotate pi over 2, or we rotate the minus pi over 2, then you can see, based upon this equation here, from the maximum value, from where the maximum value occurs, if we proceed by pi over 2 here in the rotation of the angle, then we will reach the minimum. So here we are here. If we go, say, the pi over 2 here, then in this direction is our minimum exactly match what we've been calculated here. And this is the essence of those equations here. Okay, you have to think through. And this is the first one. And then the second issue is this. The second important issue is this. If you will be able to calculate in the principal directions strain stress equal to 0, guaranteed. So that means tau x prime, y prime, you plug in the theta p here, that will be always equal to 0. It's not by incident, it's the truth. Okay, so that means for this case, if we plug in here, then the tau x prime, y prime, you can give a try, and that will be equal to 0. So that means in these principal orientations, the strain stress equal to 0, we don't draw it. Okay? And now we finish the principal stresses and for the first two equations. And then I want to fix what is the maximum value for the strain stress, and that is the second topic. For the second topic, for this one, the maximum strain stress occurs in the orientations theta s is equal to arctangent 1/2 maximum minimum value equal to plus minus r, and where r equal to the one we've been defined. Okay. The same thing, I will give you a reason why. Tau x prime, y prime is equal to minus sigma x minus sigma y divided by 2, and sine 2 theta plus tau x y cosine 2 theta. And this one taking the similar strategy